All right, so today is March 12th, and it's Tuesday. It's the Tuesday before spring break. And let me share my screen here. I don't know what this does. And so today I thought I would just go through the chapter 12 slides. Let's see, chapter 12 is chapter 12. We're not supposed to start chapter 12, but it's the chapter on classes, and it's helpful to know chapter 12 to be able to do the midterm. I gave you quite a few hints on finishing the midterm last time, but as I was looking through chapter 12 today, I realized that there's really a lot of stuff in here that's pretty relevant to the midterm. So I'm gonna might as well go through that today. I never did copy down chapter 11 either. So chapter 11 was on debugging, and you know, we covered that last semester a little bit. There's not much to that. It's helpful to learn if you become skilled at using the Visual Studio debugger. That's very helpful for debugging your large programs, but also you know, it's helpful to learn debugging skills without relying on Visual Studio, because you're going to be programming in your lifetime. You're going to be programming on systems that are not as sophisticated as Visual Studio, no doubt, especially if you do web programming. And so just being able to insert code to display out intermediate values within loops and so on is pretty it's a pretty straightforward thing to know how to do anyway. So, but let's go into chapter 12 here, and I'm just going to cover these slides here and maybe give you and see how long this takes, and maybe you can have some more time to to do your midterm. How are we coming on our midterms? Is it not that big a deal? Huh? Yeah, getting there, okay. All right, well, okay, so classes. So let me do the slideshow. And let me swap this. Okay, so how to create and use classes. Let me make this thing so I can write. Okay, so the objectives of this chapter are given specifications for an application that uses classes with any of the members presented in this chapter. Develop the application with classes. Not quite sure what that means. Use the Solution Explorer and the Code Lens feature to browse the classes in a solution. Okay, do that. Use class diagrams and class details window to review, delete, and start the members of classes in a solution. Use the peak definition window to display and edit code for a member in another class from within the class that refers to it. And so for knowledge, you should be able to list and describe 3 layers of a 3-layered application. Describe the members of a class, the constructor, the method, the field, and the property. Describe the members of a class. Okay. Describe the concept of encapsulation, how instantiation works, main advantage of using object initializers. Describe the concept of overloading a method. Explain what a static member is, how to auto-implement properties, how auto-implemented properties work, how expression-bodied properties and methods work, basic procedure for using the live code analysis feature to generate code stubs, and the difference between a class and a structure. The architecture of a three-layered application. We've got the presentation layer, which is which is basically the code, that you see that presents, that interfaces with the user. There's this middle layer, which it's called the business classes, and that's where a lot of the logic goes for more sophisticated logic for functions and so on that are specific to the application itself. And then there's the database layer, which we will get into a little bit later this semester. So members of a product class, the code. This is a specific application. It's an application that accesses products in an application that keeps track of maybe inventory, products. That's what we mean by products. And so we may have a code, a product code, which is a string that contains a code that uniquely identifies each product. We may have a description of that product, and then we may have a price for that product. And then these are properties, which are like just variables. And then we have methods, get display text, which would be returns a string that contains the code, description and price in a displayable format, and the separator parameter may be a string that's used to separate the string that's used to separate the elements. So it could be like commas or semicolons or something. This is just an example class. Constructors are when we want to create an instance of the class, we want to instantiate the class. We're creating the instance of a product, and so the default constructor would just, this is written where you have when you're creating an object, you name the object, and then you could have some parentheses. You could define your own default values, or you can leave those blank, and it just creates a default product object, which doesn't have code, description, or price in it, presumably, and then you would have to assign those property values later in the code. So types of class members, this is classes in general. We have properties, which represent a data value that's associated with an object instance. Okay, so this product class, let's say you have, 5 different, let's say you have a store and you sell 5 different products. Okay, so you would have 5 different instances of this product class, of 5 different instances of products, and the product class would sort of define, help you define the attributes of that class. Similarly, if you had a class which define people or persons. You may have properties that would be used to define a person, and that could be like color of eyes, that kind of stuff, height. So those would be properties, and then methods could be operations that could be performed on the object. Constructor would be what you'd use to create an instance of that object, and a delegate is we're not going to get into those much, but that's if you wanted to pass a particular method as an argument to other methods. An event is a signal that notifies other objects that something has happened. A field is a variable that's declared at the class level. It's like a property. And then we have constants also. We have indexers, which is a special type of property that allows individual items within the class to be accessed by index values, and it's used for classes that represent collections of objects. Operator is a special type of method that's performed for a C# operator, such as the plus sign or double equals, and then we can have classes defined within a class. So this description or chapter of classes goes into much more detail than we did in 128, and they're not really used that much. We're not going to use some of these things that much, like operators and indexes and so on. But it's in this chapter we just want to be aware of these things, because in the future you may need to learn about them and use them. Class and object concepts. An object is a self-contained unit that has properties, methods, and other members. A class contains code that defines the members of an object. And code can also define can also be used to define methods also. An object is an instance of a class, and the process of creating an object is called instantiation, and you know that. Encapsulation is one of the fundamental concepts of object-oriented programming, and it lets you control the data and operations within a class that are exposed to other classes. So it allows you to group together variables, which can be called properties, and functions that operate on those variables, which are called methods. And by encapsulating them together, the programmer who writes the class defines exactly what can be done to those properties and how things are done, and that's what the methods are for. The data of a class is typically encapsulated within the class using data hiding, and in addition, the code that performs operations within a class is encapsulated, so it can be changed without changing. So it can be changed without changing the way other classes use it. So basically, in the old days, we had variables that were separate separate from functions. They weren't encapsulated together, and it was just left up to the programmers. If the programmers wanted to operate on some data, a programmer could just write some code to operate on the data, in any old way, and there was no way to enforce certain methods of operating on the data. So although a class may have many different types of members, most of the classes you create will have just properties, methods, and constructors. So, you know, all those other things that we talk about, indexers and operators and delegates and events and fields and so on, we don't really use those that much. Some of those like delegates, there's no delegates in Java. You can't really pass a method to another method, but you can in JavaScript. It's one of the reasons why, in some sense, C# is a language more suited to you know, large programming projects, because you have these operations, these additional operators or these additional members to classes that sort of control how they're used and implemented. So this product class that we've been talking about, the fields and constructors. This is an example. So let's say we have a program or a project called product maintenance, and the idea is that we're, you know, keeping track of our products or keeping track of inventory or something like that. And we have this class called product, and inside this class we have defined a code, and we've defined a description, and we've defined a price. And price is a decimal value because it's going to be money. And then description and code are just character strings. This is the default constructor. So there's no real code associated with this, as you can see. So when you want to define something, like you know, you want to define you know, book, and we say book is an instance, or it is an instantiation of a product. If we just say that it's this without any parameters inside here, then it's going to create a default object called book, and it's going to have these couple of these properties here, code, description, and price, but they aren't going to have any values. Whereas we can also, this particular class has an additional constructor which looks like this, and with this constructor we can actually pass into it a code and a description and a price. And then when you create an instance of a product using this constructor, we're also able to, along with it, define a product code. We're able to include a description of the product and a price. And so here is the way you can access the way we've defined accessing the code property. This is if you want to access what the code is of a particular product, you know, outside the product or outside the object. This is what allows you to do it. Get, and get will return the code, whatever the value is defined up here. And set will allow you to set the code to a new value. So if you create instances of products using just the default constructor, you better have a way to be able to set the codes and also set the descriptions and set the prices. It's possible that you don't use this, and all products need to be defined this way. So when you create a new instance of a product, you know, a toy car or something, and you may at the time you create the object, you may define the code, description, or price at that time. In that case, you wouldn't necessarily need set, but you would probably still need get. And here's an example of a method which is used to display out some information about the product. And here it's a method which takes in as a parameter a separator character. It could be a comma or a semicolon or something, and it just returns a string which takes the code, appends a separator, appends the price, converted to a string, followed by a separator and the description. Simple. So here as an example, we've created two product objects that have been instantiated from the product class. And this first one, these look like they're books. Looks like they're Murrock books. This is the one we're using. So it's got a code defined as a defined code. It's got a description. It's got a price. And in this case, we're calling it product one. So we have this object called product one, and product one dot code is this. Product one dot description is this. Product one dot price is this. And it is an instance of this, generic product class. And then we've got a second product here that we've defined. Product two equals, or we have product, the word product. We would define it with the word product. Product two equals new like this, new product. Okay, here we're defining two variables, or two objects, two variables, and they're product variables. And we say that the first one is a new product, and in this case we are using the constructor that allows us to also define the code, the description, and the price. So code that creates these two object instances. Here, code that creates the object instances with object initializers. So this is just another way of doing it, where we're setting the properties equal to these string values inside the curly braces like this. Dialog box for adding a class. This is how we add a class. We can select, it's a class type. It's not a Windows form application. It's just a class, and we can type the name of it down here. Click add, and this code thing pops up. It's going to be the namespace of the project. And it's all ready to, it's the name of it is what we called it back here. And then we're able to start typing in the code. Here we're going to add field declarations. Quantity, price, this is going to be different. This is public fields. display text. This is same as before. And here, syntax for coding the public property. This is accessible from the outside. This is the get the accessor code, set the accessor code. This is accessor is property accessible on the outside. This is where we have read write, where we have set write, whereas read only we do not have a set. Here's a you know, you don't have to just use get and set to access properties as variables. You can also, you know, include some operations within the get. So here, for example, we're returning a discount amount, which actually is a result of a calculation. Here's a statement that sets the property value. Here we're this is on the outside where we have an instance of a product named product, lowercase, and here we're just setting. This looks like it comes from a text box, and we're just setting the code property of this product to what was in the text box. And this is a statement that gets a property value, where this is how we would access the code value, and using this code inside of the class. Let's see, these are I'm going to switch over to the textbook. I think it'd be better if I switch. Let's see. Let me go to vital source. It's in here, isn't it? Yeah. Chapter 12. Oh, my goodness. Let's see. All right, looks a little bit better. So yeah, this looks a little little bit better. So here's an example, or this is the basic layout of a class. Got the fields up here, got the constructors here, these things here, and then we've got this is the code property and how we access the code property. This is the description property, and this is the decimal, the price property, and this is the method for displaying out text or displaying out a product. And how instantiation works, we can do it this way, where we create a new product and set the properties that way. And so here's an example of here's what the example was before, where we've created these two objects, the product 1 and product 2, the two different books. This is how we can create them. And so when we add a class file to a project, we can do it several different ways. We can right-click on the project in the Solution Explorer, and this thing pops up, or we can actually just create the class directly that way. And this is what the starting code looks like. Recall this. So to add a new class, we can use project add new item command, and this thing pops up. We can just, there's also just an add class directly. How code fields work. These are some example field declarations where we add the private and the public in front of it. We can say that they're read-only. A version of the product class that uses public fields instead of properties. So same kind of thing. A variable that's defined at the class level within a class is called a field. A field is a primitive, can be a primitive data type or a class or a structure. You can use the private access modifier to prevent other classes from accessing the field. An instance variable is a field that's defined in a class and is allocated when the object is created or instantiated. You can create a read-only field by specifying read-only, and a public field is declared using the public access modifier. So here's how you access the properties. Read write, read only is just get. You can code the get. You can code a get accessor to retrieve the value of the property. You can code a set accessor to set the value of a property. And a property that has both a get and a set is called a read write property. Pretty obvious. How to code methods. You've got the whether it's public or private, you got the return type, if it's going to return a value or not, or just be void. Now you got a name and you have a parameter list. And so here's an example of it accepting. Make this a little bigger. A method that accepts parameters. So this one is going to accept a parameter here, which is the separator, the example that we've been using. And this here, this is an example of overloading. Okay, so by overloading, we just mean that we're using the same name for a method, but it's actually two different sets of code. And the way that we tell the difference is we have this signature for the method, and if they're not exactly the same, then we can do it. So this one is not the same as this, because this one here has got a parameter and this one doesn't. So we are overloading this method. There's more than one of them. The name of the method combined with its parameters form the method's signature. Although you can use the same name for more than one method, each method must have a unique signature. You can create, when you create two or more methods with the same name but different parameter lists, the methods are overloaded. It's common to use overloaded methods to provide two or more versions of a method that work with different data types or that supply default values for omitted parameters. So in this example, you know, we might normally say, when we want to display out the text or display out what the product is, we're going to include a separator because sometimes we might want to use semicolons, sometimes we might want to use commas or whatever, or we might want to use tabs. But we also may want to just have a default where we don't, where if you don't want to bother specifying a separator, then you don't need to, and it'll use a default separator, which is a comma followed by a space. And so this is an overloaded version. So you can do it, you know, either way. How IntelliSense feature lists overloaded methods. So it's got one of two, two of twos, just like that. Constructors, how to code constructors. This is what you use to create an instance. So this is a constructor with no parameters. It's just like this. It's the properties are not defined yet. You got to define them sometime. Here's a constructor with 3 parameters. You include these values, and the constructor inside here defines what you do with them. Here's a constructor with one parameter. Here's a statement that uses all 3 of these constructors. So these are the default values for instance variables. So there's defaults here where if you have a numeric type that's not assigned anything, it's going to default to 0. Boolean variable is going to default to false, and these other things are going to default to null, and the date is going to default to January 1st, year 1. All right, so what's next? How to code static members. Okay, so static classes are a little different. You don't need to create an actual object instance of it. A class that contains static members. So we have a static class called validator, and it's got a private static string. The title of it is entry error, and you can read and write the title. And we've also defined a Boolean variable is present. And so this is a validator class. And so code that uses the static members if this is the text box that we passed in here, if this is present, looks at the text box, this text box called text box, lowercase text box. And if it's empty, then it's going to display out the name of it, which is going to be attached to the tag, I guess. And it says that it's a required field. And so this is how you use it. It uses the validator class. You don't need to create an instance of it. You can just use it. It's because it's static, and it just tests to see if the what's in the text box. We have 3 text boxes here. We've got a text box called txt code, one called txt description, and one called txt price. And this thing tests to see if the user filled in something for each one of these 3 fields, or each one of these 3 text boxes, and if the user did, then it returns a true. Otherwise, it returns a false. A static member is a field, property, or method that can be accessed without creating an instance of the class. To define a static member, use the static keyword. Static properties and methods can refer only to other static members or to variables declared within the property or method. If you create an object from a class, you can't refer to a static member through the variable for that object. You can refer to the static member only through the name of the class itself. If a class only contains static members, you can use the static keyword in the class declaration to declare the class as a static class. C# 2015 provides a new using directive that lets you refer to static members of a type without naming the type. Okay, here's a product maintenance application which goes through and uses all these things that we've just learned, creating where we create these forms. This is a new product form. This lists out products, and so I don't think I'm gonna go through this. I think what I'm gonna do is I'm gonna create a little assignment out of this, but I'm not gonna give you this assignment until after you're done with the midterm. Okay. So this is chapter 12, and if we look at our syllabus, chapter 12 starts Thursday and goes past spring break. So and today is this day. I just wanted to. I don't know how valuable this lecture was, but what I've done is I've exposed you to the section of the book that covers classes, and classes, is something that you need to know how to do for the midterm, and so it's a good reference for you. And so I think I've done that, and so I think I will leave it there for now. And if you have any questions on the midterm, you can bring them Thursday. Otherwise, I'll probably go over this a little bit more and cover maybe the simple assignment that I'm going to create from chapter 12 here, where we're actually creating this little application. All right, so I guess I can just let you continue working on your midterm. That's what you're doing, right? So are there any questions? All right, I think I'll leave it at that today, and see you Thursday.